Welcome to Spring LIB.
All right, so we have a spaceship in distress, and it launches two pods in opposite directions, but with slightly different velocities. And so P1 has velocity of plus 0.7 c, so we implicitly assume that this direction is positive, and P2 has negative 0.8 c. It's moving, so it's moving with 0.8 c the direction opposite to P1. Okay, that's our convention. So the first thing, obviously, to do is set up reference frames. And so S prime, I'm calling the reference frame the ship. Let's just put that in there. Make sure you know that this is the ship. This is S prime. P1, S is P1, which is pod 1. And so we want S, we choose pod 1 to be S because it is the reference frame where you want to find your final measurement. So you want velocity of P2 as measured by P1, which is why S would be the reference frame there. Whoops. So relativistic addition of velocity formula is U equals V plus U prime over 1 plus VU prime over C squared. And so V, in this case, would be S prime with respect to S, meaning velocity of ship, with respect to P1. And so P1, as it's moving away at plus 0.7 c, it will appear to it as if the ship is moving away at plus 0.7 c as well. U prime is the velocity of P2, which is this pod, with respect to with respect to the ship. So this ship sees it moving away at negative point at negative 0.8 c, and so that would be negative 0.8 c. The thing to note here is that this isn't exactly the formula we're using. We're actually using a different version, which is v minus u prime over 1 minus vu prime over c squared, because P2 is moving away from P1, which is why we'll have here, well, that's just an implicit what we're using. So, which is why we have here, it's minus, so positive 0.8 c. Okay, so 0.8 c is u prime, and it's basically v2. It's basically negative of v2 because you're moving away from P1. Okay, and then divide that by 1 plus 0.7 c times 0.8 c over c squared. And so this gives you 1.5 c over 1.56, and that is 0.962 times the speed of light. And that's it.